we invest the unknown with a certain romance. The yet to be seen, the mysterious, the uncharted. It's been speculated that this comes from an innate nomadic impulse within us. We're always trying to see what's beyond the horizon. So perhaps it's little surprise that when people wax poetic about the universe, they focus on the unknown. That's certainly what drives the scientists. But in this focus on the unknown, people often think that we've disenchanted the things that we do know about the universe. I'd like to spend this video pushing back. I'd like to discuss one of the earliest encountered phenomena, gravity, in as deliberately poetic a way as I can. So let's start with an event. The smallest possible piece of spacetime, a single, unified answer to the questions of where and when. But how shall we know an event? At first glance, a chart of coordinates would seem to be in order. But the principle of relativity rings in our ears, reminding us that no point of view is privileged over any other. So every vantage point will chart different coordinates. This is useless to us. Instead, we shall know an event by what happens there. Every event is connected to its neighbors, past and future, by causality. Every event is both cause and effect, an instant in the great chain of history, cascading from past to future in a topology called spacetime. Not everything is connected to everything else. There is still the speed of light to think about. But all things are connected by chain to an infinite continuum of past and future events. Every moment is connected to an infinity. To the hasty eye, this may start to smell of fatalism or predestination, but we're more careful. Conservation of momentum, which is known by many mantles to us, tells that for every action, there is an equal and opposite reaction. So an event influences its environment just as much as the environment influences the event. And recall that there is no reason to privilege one of these vantage points over another. Speaking of momentum, it is crucial to how gravity plays its role. To demonstrate, behold a globe, like the Earth. Two people stand on the equator, thousands of miles apart, but both facing north. Dutifully, they begin their march, never wavering, straight forward along the surface of the Earth. Despite beginning their journeys parallel, by moving through a curved space, they nevertheless become intersecting. This is no metaphor, by the way. This is no analogy. This is how it really works, just in fewer dimensions. Objects moving straight forward through a curved space become drawn together by a force that we call gravity. Where could this curvature spring from? You'll often hear that the answer is mass, but that's not quite right. The world's most famous equation tells us that energy and mass are equivalent. But the equation that the world's most famous equation comes from tells us that energy, mass, and momentum are equivalent. Curvature comes from mass, energy, or momentum, or any combination of the three. We'll call this collection MEM. Many parts of the universe lack mass, but everything has MEM. Everything creates curvature. That curvature gets communicated across the vast reaches of space at the speed of light, attracting everything in its path slightly. MEM, an intrinsic property of every discernible subsystem of nature, creates a small but very real attractive force between everything that exists. How beautiful it is that it's in the nature of all things to find each other. Now, it's not the only nature of all things, and counteracting forces can certainly get in the way. Sometimes that's a very good thing, like preventing me from falling into the core of the planet below and combusting in the heat. But nevertheless, gravity is always there. There are some visions of the other forces which account for them in exactly this same kind of geometric way. I would very much like for that to be true. I think it would be very beautiful. But I've been wrong before, so we'll have to wait and see. And even if it were true, there would still be something special about gravity. But to show you this, I hope you will indulge me some thermodynamics. Normally, the ceaseless accumulation of entropy demands that systems become more featureless over time. Fluctuations in heat or matter are spread, and temperature reaches an equilibrium state of cold uniformity. But in systems dominated by gravity, something different happens. Imagine a cold universe, filled completely with a perfectly uniform crystalline lattice of isolated atoms in the void. Nothing happens here. Nothing moves, because every atom feels drawn equally in every direction. But then, suppose a single atom wavers from its place. Suddenly, we have a fluctuation. Gravity will pull the defect apart, clustering the compacting atoms together until it forms into a star and planets and life and culture and technology and spacefaring sojourns and so on, ad infinitum. Because the interaction of gravity is always attractive, inhomogeneities are magnified. Gravity is special because it is the only force that accomplishes this creation of complexity spontaneously. And that's the final lesson that gravity has to teach us. Because all things are connected to an infinity. Because it is the nature of all things to find each other. And because gravity alone can create complexity where once there was none. A single atom can change the fate of thousands of worlds. Imagine what a life form could do.